In this video, we aim to learn how to find the probability density function of a random variable, provided that the distribution of the input is given. In other words, I assume that a random variable x is given with a provided density function. So we have the PDF of x, fx of x, and we aim to, and a function g of x is also given, and we want to find the PDF of y, fy of y, in terms of y. So we want to know how we could determine this. We will develop a very specific procedure for that. So for a given value of y, if it is not in the range of g of x, in other words, if y equal g of x has no solution, automatically we could say that the PDF of y is 0, because for no values of x, such a value of y is produced. Therefore, for a given y, we shall determine the set of all solutions of y. Specifically, if you have a unique solution, our job is easy. If you have no solution, our job is easy. If you have multiple solutions, yeah, it's easy, but we have to add some of the terms. So we aim to prove this theorem. We say that the PDF at any given point y is summation over, this is the set of all solutions. So G inverse of y is the set of all solutions of y equal g of x. So we have to try to solve this one, and for different values of y we have to find the solution. Once you get the solution or expression of the solutions, you can calculate the PDF at different solution and then divide it by this guy, and we will learn about it. So we'll prove this one and learn about the detail of it very soon. So suppose that this is your function y equal g of x, and this is the value of y. Okay, so for this value of y, I consider a small interval, this one. In this interval, if y wants to be bigger than y and smaller than y plus dy, okay, probability of this guy is approximated by, provided that dy is very small, is equal to fy of y times dy. So if dy is tends to 0, this approximation becomes exact. So this is how I want to calculate fy of y. So I will divide both sides by dy, and I will have the PDF. Now, in this interval, if y wants to be in this interval, what are the values of x on this axis which are mapped into this interval? Now, if for this y I get this solution, and for y plus dy I get this solution, so if this is, let's say this is your first solution, and this is x1 plus dx1. So all the points which are in between these two are mapped in this interval. So this event is equivalent to say that this event is equivalent to say that x is between one of the solution, x1, and x1 plus dx1. Or alternatively, if x is in this interval, so union of all these subintervals. So these subintervals, where one of these points is solution and the other one is the other one. Now, suppose that this is x and this is your PDF of x, okay? If you want to calculate probability of this guy, you have either x should be in this interval or this interval or this interval and this interval. Probability that x is in this interval is equal to this area. X is in this interval is this one. So if I add these probabilities, I will get this one. So I could say that this probability is equal to probability summation of probabilities that x is between xi and xi plus dxi, obviously absolute value of this one. And these probabilities is approximated by fx of, let's say, xi times dxi. Okay? Now, if I divide both sides by dy, I get this expression. So if I have this one, this equation, I have f y of y times dy, I put it the other side, is equal to summation over xi, and xi is the set of all possible solutions, so it's in g inverse of y. And then I have fx of xi, and then I have to divide this by dy divided by dxi. And I have to put absolute value because sometimes here this dx is positive, here is dx negative. So it doesn't mean that I subtract this one. So this is why I have absolute value. So the proof is complete. It is very intuitive and is very complete. So this is a very important theorem. So in other words, if I want to summarize, this event y being in this teeny tiny interval is equal to the event that random variable is in one of the sub-intervals that are produced by solutions of y equal to g of x. You get the solution of x1, x2, etc. And the relationship between dy and dxi is just equal to d of g of x with respect to dx. Then you replace x by xi. And therefore, the proof is very easy. So you see that the PDF of these times this one, which is probability of this guy, is equal to probability of these, and this is probability of this side, and then you can write it and go ahead. So this is a magic formula that we will use it very easily, and using this magic formula we develop a procedure to find a PDF of y directly from the PDF of x and from function y equal to g of x. Here we have seen that first step is to find the set of solution. Then we have to calculate derivative of this one, which is g prime of x, and then replace this by xi and then put it on the denominator here. So in summary, we have several steps. First step is to solve this equation, find the set of all possible solutions, and we denote this as a set. If it is empty, the PDF is empty. If the inverse of this set of solution is empty, for some y, the PDF of y is 0 for those points. The second part is this event in terms of x, we can find a solution. Third step is to find the derivative of y with respect to x, replace it with the solution. Remember that here the set of values for here is g inverse of y. Let's say you have x1, x2, etc. You write these guys in terms of y. So x1 itself is a function of y, x2 is another function of y, etc. And then we substitute it in this magic equation.